Okay. Alright, today we are reviewing factoring. We're going to talk about two different methods. We're going to talk about the box method. We're talking about the guess and check method. There are a million different methods. So if you go online, you find a method you like, use that method. Alright, we're going to talk about two methods. I use guess and check like every single time. If you like the box method, use the box method. Alright, we're going to go through both of them. Tomorrow we'll do more factoring stuff, like we're actually playing factoring bingo.
Yeah.
So we're going to practice even more tomorrow, but like I said, we're doing it today too. So, guys, almost our whole unit is based off of factoring. So if you can't factor, we got to figure out a way to make it so you can factor. Alright? A lot of our units will be based off factoring. So, first things first, you should ask yourself, are there common factors? That is the first thing you should always ask, because if they have common factors, you should always factor them out, right? Factor out the greatest common factor. So example 1, 2x squared y minus 6xy squared. The first thing I should look for is, do they have common factors? And yes, they do. Right, if I look at it, 2 and 6. Right, what's the greatest common factor between those? 2. So 2, x squared and x. The greatest common factor would be x. Y and y squared? Y. So I'm going to pull that whole thing out, 2xy. I'm taking it out. If I take that out of this first term, I'm left with just x. Right? Minus, if I take it out of the second term, I'm left with 3y. Right? Does that make sense how we just factored that out?
Yeah.
Took that greatest common factor out. Okay. That is the first step, no matter what type of problem we're doing. Whenever it says factor, you should always look to do that first. Alright? Same thing with the second one, 9x squared minus 27x. Looking for greatest common factor between these two things. 9 and 27, it'd be 9. X squared and x, it'd be x. I'm left with x minus 3. The reason we do this is because when we start like factoring trinomials where we have like x squared, blah, 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 blah. If you take those numbers out, those greatest common factors out, it makes things so much easier. Right? A lot smaller numbers you have to work with. Okay? Cool? Alright. Any questions about factoring things out? Okay. Second thing you should look for. Is it a difference of perfect squares? So let's think about that statement. Difference of perfect squares. What does that mean? What does the word difference in math mean?
Subtraction.
Subtraction. So I'm looking at my piece that I need to factor. I'm looking, does it have subtraction in it? Then I'm looking to see, is it between two perfect squares? What are perfect squares? Those numbers up there, what about like, is x squared a perfect square? Yeah. Is like z squared a perfect square? Is like y to the fourth a perfect square?
Yes.
Yeah, right? Y squared times y squared would be y to the fourth. So it's anything where we can multiply the same numbers by itself to make it would be a perfect square. So the next thing you look for, is it a perfect square? Or difference of perfect squares? Well, x squared minus 25. Difference, I have subtraction. X squared, is that a perfect square?
Yes.
Is 25 a perfect square?
Yes.
Okay, so then it's super easy to factor. What's going to happen is, what's the square root of x squared? X, what's the square root of 25?
5.
So I get x plus 5 and I get x minus 5. And that's factored. So I take the square root of both pieces. One of them I add them. One of them I subtract them. Okay, same thing for the second problem. 16x squared minus 25y squared. Is 16x squared a perfect square?
Yes.
Yeah. Is 25y squared a perfect square?
Yes.
Do I have subtraction?
Yes.
Yeah, so I can call it a difference of perfect squares. So if I take the square root of this first piece, 16x squared, I get 4x, because 4x times 4x, it gives me 16x squared, plus square root of 25y squared would be 5y. Then I'm also going to write 4x minus 5y. And that's my answer. That's factored already. So step 1, look to see if you can factor anything out of our problem. Step 2, see if it's a difference of perfect squares. If we get past that step and we still haven't factored it yet, that's when we're going to get into like box method, guess and check, things like that. Okay? Any questions so far? Cool. First method we're going to talk about, box method. Alright, if we have ax squared plus bx plus c, we have three terms. How many of you like using the box method? Or remember? Okay, how many of you are guess and check people? How many of us don't know yet? Perfect, that's fine. Okay? So, there are several methods, like I said, guys. I think another one, I think Miss Billow even uses the star method or something like that. I know, I've never used it. If you want to use that one, or there's like factoring by grouping. I've never done that either. So if you need help with something like that, I would not be a great resource. But like, I know Miss Billow knows how to do it. I know the internet probably knows how to do it. So we can figure it out. Find what you like and use it. So, first one we're going to use is box method. 6x squared plus 7x minus 24. I want you to factor that. Well, if you use the box method, what you're going to do is you're going to take your ax squared, or your first term, and you're going to take your c. And you're going to put them in their separate pieces. 6x squared goes top left. Negative 24 goes bottom right. That would be first step for box method. Step 2 then. Multiply a times c. 6 times negative 24 should give us negative 144. What that tells me is I'm looking for factors of 144. I'm looking for factors of 144 that add to 7. Right? So what are some factors of 144? 12 and 12. Does that add to 7? No. Remember also, one of them's got to be positive, one's got to be negative. So they should multiply to negative 144, right? Okay. What are some other factors of 144? Miss Larson? 16 and 9. Is there a way where one of those is positive and one's negative that it will add to 7?
Yes.
Yeah, how? So I'm going to put one of them top right, 16x. One of them bottom left, negative 9x. Now that my boxes are full, I'm going to take and I'm going to factor each column and each row. So 6x squared and negative 9x, 3x. You can pull it out. 16x and negative 24 would be 8. 6x squared and 16x, 2x. Negative 9x and negative 24, negative 3. If there's a negative for both, we're going to pull the negative out. Okay? So then my factored answer should be 3x plus 8 times 2x minus 3. And it's all factored. Right? So first up, ax squared and c. Multiply 8 times c. Find factors that add to your b term. Add to 7 in this case. And factor it out. Hey guys, is there any possible way you could check to see if you got the right answer? Foil. Right? Multiply it back out. If you foil it, you multiply it back out, you don't get the same thing you started with. It's wrong. Right? It should work both ways. Okay? Any questions? Okay, let's try one more of those. One more box method. I know we have a bunch of them on there, but if we don't keep moving, we're not going to finish. So, I don't want that. Alright, next one. I look at it. It says 18x squared minus 15x minus 12. Step 1 should be what? Wrong. Step 1, what I say you should always look to do? Factor a GCF out. Factor a GCF out. In this case, I can take a 3 out. 3 times 6x squared minus 5x minus 4. Alright, we took a GCF out. We are going to use the part inside the parentheses for our box method. That 3 will come back to later, but we're not going to need it right now. Okay? So now is when we put our ax squared, our 6x squared, and our c, negative 4, into their boxes. So now we take 6 times negative 4, which is negative 24. We need to find factors of negative 24 that'll add to negative 5. Well, I know like 1 and 24, 2 and 12, 3 and 8, 4 and 6. Do any of those work? 3 and 8, right? If I have positive 3 and negative 8, it should give me negative 5, right? So you can put them in whichever boxes you want. Oops, I did that backwards. Positive, negative. Okay? It doesn't matter if you put 3x on top right or you put negative 8x on top right. Either one should work. So I'm going to go ahead and I'm going to factor them out. 6x squared and 3x will be 3x. Negative 8x and negative 4 will be negative 4. 6x squared and negative 8x will be 2x. 3x and negative 4 will be 1, right? If they don't have any common factors, 1 is always a common factor. So my final answer should be 3x minus 4 times 2x plus 1 with the 3 in the front. Don't lose this 3. It's got to come down to our final answer. Right? If you factored it out, it's got to be in your final answer. Yes?
Does it matter if you have like the 3x minus 4 like in front or?
If you flip these around?
Yeah.
Does not matter.
Okay.
As long as you have the correct set, so you have 3x minus 4, you have 2x plus 1, doesn't matter which one comes first.
Okay.
Great question. Yes, Sid?
Wait, so then, when you like factor it, are you only applying the 3 to the first parentheses?
Technically, yes, and then you could FOIL them.
But wouldn't it be different than depending on what
It would not, because 9x times 2x is 18x, right? If I distribute 3, I get 9x. And when I FOIL, I would do 9x times 2x, which is 18x, right? Okay, if I distribute 3 to 2x, let's say it's first. 6x times 3x is 18x. So it wouldn't matter which one we distribute it to, because when we FOIL it, they all go together anyway. Okay? Good question. Really good question. Any other questions? Okay. Let's do one more. We'll do one more. We should have time. Okay, you're not gonna try it on your own, we're gonna do it together, so I want to go through it. Okay? So, 6x squared minus 19x plus 10. First step should be to look to factor anything out, right? GCF. GCF, same thing. Can I do that? Do I have a GCF? No. 19? Alright, so, no, there's no GCF here, so we need to start putting stuff into our boxes. 6x squared and 10. Right? 6 times 10 will give me 60. Over, or not over, but factors of 60. 6 and 10. 3 and 20. 2 and 30. 4 and 15. Any of those that add to negative 19? 4 and 15. And they both have to be negative. Alright guys, this is where the box method gets kind of tricky. Now we said before that they both had to be negative when we take GCFs out of our boxes to make it negative, right? This is a special case where it's the opposite, right? If both of these are negative, then when I pull things out, they're going to be negative as well, because they need to multiply to a positive, add to a negative. Okay? So if I go 6x squared and negative 15x, I'm going to get 3x. But when I do negative 4x and 10, I'm going to get negative 2. 6x squared and negative 4x is giving me 2x. Negative 15x and 10 is going to give me negative 5. Alright, so this is where the box method gets kind of tricky, because normally we say they both have to be negative. We should get 3x minus 2, 2x minus 5. And remember, FOIL them out to make sure you got the correct thing. Alright, guys, any questions on that? Okay, that is our box method. Okay, we're going to guess and check next. Alright. I do believe this one, the second box method one that we didn't get to, that should be on Schoology. So if you do want to try it and then go check it on Schoology, you can. Okay, method 2, guess and check. Same thing that we started with. See if you can take a GCFO. Can we? No. So the next thing I got to look at is I'm looking at A and C. So I have 10. Oops, that's not very good. I have 10 and I have 8. I'm looking for factors of both 10 and 8. Well, factors of 10, 1 and 10, 2 and 5. Factors of 8, 1 and 8, 2 and 4. Now, it's literally guessing and checking here. I'm going to take 2 factors of 10, and that's going to be my 2 x values. I'm going to take 2 factors of 8. Those will be my constants at the end. Now, before I start doing that, I'm going to think. So I got to figure out, are these going to be plus or minus inside? If I'm multiplying to a positive, adding to a positive, they should both be plus. They should both be positive, right? So, Larson, pick a pair of factors of 10.
2 and 5.
2 and 5. Okay? 2, pick a factors of 8.
2 and 4.
2 and 4. Okay. So I'm going to try 2x plus 2, 5x plus 4. I'm going to check. I'm guessing, checking. So I'm looking to see, when I do their x values, do they add to 21x? 2x times 4 will give me 8x. 2 times 5x will give me 10x. That gives me 18x. Is that what I was looking for? No. So I know that's not the right combination. Well, I'm going to try 2x. I'm going to switch the 4 and the 2. Plus 4, 5x plus 2. 2x times 2 is 4x. 4 times 5x is 20x. Is that what I was looking for? No. So I know this combination won't work. I got to try another one. Right? What other one do you guys want to try? 1 and 8 instead of 2 and 4? Okay, so if I go 2x plus 1, 5x plus 8, we'll say 2x times 8 is 16x, 1 times 5x is 5x, equals 21x. Is that what I was looking for?
Yes.
Yeah, so that's my answer. Right? It's literally guessing and checking. That's why they call it the guess and check method. Now, as you get better at it, and as you think about it more and you do more problems, you're going to be able to go way quicker. It might only take you 1 guess. It might only take you 2 guesses. But some of them, when they're really difficult, might take you like 4 or 5 guesses. Alright? Like I said, the better you get at it, the quicker they'll go. Does that make sense? Okay. Let's try another. 6x squared minus 11x minus 10. First and foremost, is there a GCF I can take out? No. So I'm looking for factors of 6, factors of negative 10. Or just 10, right? 1 and 6, 2 and 3, 1 and 10, 2 and 5. Now, when I go to write these out, I'm looking for 2 numbers that multiply to a negative and add to a negative. Well, can I have both positive numbers and multiply to a negative? Can I have both negative numbers multiply to a negative? No. So I know one is going to be positive. I know one's going to be negative. And I'm going to guess and check. TJ, pick a pair of factors for 6.
2 and 3.
Okay. Natalie, pick a pair of factors for 10.
2 and 5.
2 and 5. So I'm going to try 2x plus 2, 3x minus 5. Just going to try them out. 2x times negative 5 is negative 10x. 2 times 3x will be plus 6x. That gets me negative 4x. Is that what I'm looking for? No. Try a different set. So I'm going to try 2x plus 5, 3x minus 2. Negative 4x, 15x. I get positive 11x. Is that what I'm looking for? No, but it's really close, right? It's the positive version of what I'm looking for. So I bet if I switch this plus and that minus, I bet I'll get negative 11. So instead of 2x plus 5, I make it 2x minus 5. Instead of 3x minus 2, make it 3x plus 2. 2x times 2 is 4x. Negative 5x times 3x is minus 15x. I get negative 11x. That's what I'm looking for. So that's my answer. Does that make sense? A little? Okay. Did we all find a method that we think we can use today? Whether it's box or whether it's guess and check? Yes. No.
Yes.
Okay. Do we want to try another problem? Do we want to get our homework?
Yes.
Okay, we have about 5 minutes left. I will give you your homework. Those other two are on School of Once again if you want to check them out.